In this video, we are going to consider some examples to verify whether the given array of numbers or list of numbers form arithmetic progressions or not. Now we can consider some example sequences and some examples on arithmetic progression, in short AP, and the example which states that which of the following array or list of numbers form an arithmetic progression. If it is arithmetic progression, if they form AP, write down next three terms of the following list. One is 4, 10, 16, 22, so on and so forth. The second one, 1, minus 1, minus 3, minus 5, so on and so forth. The third one is minus 2, 2, minus 2, 2, minus 2, so on and so forth. Fourth one is 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, so on and so forth. Fifth one is 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, etc., etc. Now, we can see the solution of this equation. Consider 1, minus 1, minus 3, minus what is that? Minus 1. This is not 2. This is a minus 3, minus 2. And A3 minus A2. A3 is here, minus 3, plus this one, minus 3 plus 1, that is again minus 2. And therefore, AI minus 1 is a minus 2 only. So the given sequence is, now we can, this minus 2 is a common difference, and therefore given sequence is arithmetic progression. And next three terms you can see here, there are four terms here. Fifth term, A5. A5 is obtained from A4 plus common difference D, that is A4 plus minus 2. A4 is that is 5, minus 5, plus this one is equal to minus 7, and A6 is obtained from A5 plus minus 2, that is A5 is a minus 7, minus 2, that is a minus 9, A7 is going to be A6 plus minus 2. A6 is minus 9, which you have obtained, minus 2, that is a minus 11, so on and so forth. And therefore, we have done in this case. In next, I would like to consider third one. Third one is minus 2, 2, minus 2, 2, minus 2, so on and so forth. So now observe, and in this case, A2 minus A1 is equal to 2 minus of minus 2, that is 2 plus 2, that is 4. And A3 minus A2, A3 is minus 2 here, minus A2, A2 is 2, that is going to be minus 4, and therefore A2 minus A1 is not equal to A3 minus A2. Thus the sequence is not AP. And the third one, not third one, I would like to take fourth one. 3 and 3 plus 2 root 2, root 2, and 3 plus 2 root 2, and 3 plus 3 root 2, whether it is AP or not. Now observe here, very easily one can see that AI minus 1 equal to root 2 for every I equal to 2, 3, 4, so on and so forth. Everywhere the common difference is the same, that is a fixed number, and therefore it is a AP, arithmetic progression. Fifth example is concerned, we can have a think over a little bit on fifth example. We can see here the example 5 is concerned. Can you form an AP from the list of numbers 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, etc. by a suitable definition? Means it is the statement itself says that it is not an AP, but however we can see here, I would like to rewrite the sequences as 1, 1, 1, 1, 2, 2, 2, 2, sorry, 3, 3, 3, 4, 4, 4, so on and so forth. And now I would like to write down the terms as A1, A2, A3, A4, A5, A6, A7, A8, A9, so on and so forth. Now look at the pattern of the numbers arranged in an array. Here we can see A2 minus A1 is equal to 0. 1 minus 1, 0. And A4 minus A1, A3 is equal to, A4 is a 2 minus A3, that is A3 is, what is that, 1. 1, that is 1. So there is no fixed number. I mean, that is, there is no common difference. For every pair of numbers in the array, and therefore it is not AP. However, we can see some pattern in the arrangement of the numbers listed above. What is that pattern? With that pattern, can you form an AP, rewrite the sequence in a different fashion? Now you can see, we define BI equal to I, a triple of numbers for I equal to 1, 2, 3, so on and so forth. Now we can write down this as rewrite. We can rewrite it as 1, 1, 1, a triple of numbers. This is a B1 I would like to write down, and 2, 2, 2, 2. This I can write down B2, and 3, 3, 3. So I can write down B3, and 4, 4, 4 as B4. So we can have a certain kind of a sequence here, B1, B2, B3, B4, etc. Next we define BI plus one. Let us say BI plus 1 is equal to I plus 1 as I plus 1, I plus 2, I plus 1, I plus 1. 1 is added to all the numbers in the triplets. So Pi plus 1 it can be written in this fashion, and therefore each Bi is obtained from Bi minus 1 plus 1, and for every I equal to 2, 3, 4, so on and so forth. And therefore, with this definition, B1, B2, B3, B4, etc. form AP. Now you can see, because BI minus 1 is equal to 1 for every I equal to 2, 3, 4, etc. Therefore, in this way, we can form a new sequence out of the given sequence as what you can say, from the given sequence we can find a new sequence which form AP. Now when we can observe, just think a little bit and observe the pattern carefully, and whether we can form a arithmetic progression or not. However, if it is not so, if there is a pattern, certainly, if there is a pattern, then we can form arithmetic sequence. Though it is not arithmetic progression,